Okay, so today we're going to continue with exponential functions, and we're going to look at the growth and decay models. So when we're looking at exponential growth, you can see that we are going to use this equation right here. So let's take a minute and let's write down, where are we at here? Oh. Hold on. Pen's not working. Okay, back in business. So today is 3/19/2014. We want to title this Growth and Decay, and this is the exponential growth model. So we need to know this equation. Y equals C1 plus RT. And you can see C is the initial amount. Now a lot of times you will see P used, or P sub O, and that stands for principal. And we'll do that more with money. Or sometimes they'll use C. So it kind of depends on what you're talking about here. But no matter what the variable is, you're going to use the same thing here. Here is going to be the amount you start with, your rate, which should be your percent, and then your time here. So let's look at an example here. Here we deposit $500 in an account that pays 8% interest that's compounded yearly. What is the balance of the years? So we want to take our amount, and remember I told you to use P sub O on this one. So R to the T is our equation. So we're going to do Y equals, we're going to put the initial amount, which is 500, 1 plus the rate is 8%. So we need to put that in a decimal. So remember, you divide it by 100. So it's going to be 0.08. And compounded yearly means they're getting the interest, they're calculating the interest every year. And so we want to know for 6 years. So that's the exponent of 6. So we want to take our calculator out here, and we'll just put it in here. Hopefully if it turns on. Okay, so I put my 500. And I have my parentheses 1 plus 8%, which is 0.08, and I want to know for 6 years. So I got to raise it to the 6th power, and I should find that I will have $793.44 after 6 years. Okay? So that would be a growth. We increased the amount that we had, right? So if I wrote that down, let's see, where'd that guy go? 793.44, right? So we had $793.44. So if I wanted to know how much interest that is, I could subtract the 500 I started with, right? And I would find that I gained $293.44 in interest for having my money in there for 6 years. Okay. This is the same type of thing for the growth. We're going to practice this some more in class. Then the decay model is just like what we had, except decay, you should know, means you're losing, right? So it's the exact same equation, but with a minus in it, because you're losing the amount, not gaining the amount. Like interest, you gain money. And decay, you would be losing money, or a lot of times it's used in biology for half-life. So in this case, we're looking at a car. Cars depreciate. The minute you drive them off the lot, it depreciates 10% in value. Just a little quick piece of information for you there. So if we look at this one, and we want to use our equation here, this time we have Y equals, and we can use C or P, it doesn't really matter, but we have 1 minus the rate to the T power. So here, I put in my $18,000 as my original amount. The value of the car will be worth less each year, and the car depreciates at a rate of 12%. So we have 1 minus 0.12, because we divide that by 100 to put in a decimal, and then raise it to the 8 years, right? So again, you want to take your calculator. We'll put in our $18,000 that we bought it for. Not a lot of cars you can buy for that anymore, but we're going with it. Minus the 12%, so 0.12. And then over 8 years, so we raise it to the 8. So we'll find that after 8 years, our car is going to be worth $6,473.42. So 8 years, it goes down quite a bit, right? Okay. So just basically we have the growth rate, which is the plus, and you want to make sure you know the exponential decay is the minus. And that's really basically it. We're going to spend some time tomorrow looking at growth and decay. So make sure that you understand these two equations and you understand the two sample problems. Make it short and sweet for you tonight, and I'll see you in the morning.